What? Dynatrace can do that with OpenTelemetry? No way.
Hello and welcome once again to another edition of Dynatrace Can Do That with OpenTelemetry. I am Adriana Villela, and once again with me, I have Henrik Rexed. Welcome, Henrik.
Hey, thanks for having me again.
Yeah, super excited. And last time you were here, we got a lesson on an introduction to DQL. And today you're going to take us through some more complex use cases with DQL. So what are we going to learn about today specifically?
So you explicitly asked me to do an advanced section. So this is how I'm gonna. When I'm preparing this one, I say, how can I make it the query that will break people eyes and make you sweat? Then I found the right one. So so we are going to play with Grail. We are going to cross the various signals that Grail has. So going through metrics to SmartScape to spans. We could have gone to logs, by the way, but if we have time, we could just trade out and go to logs. But here, I have a use case that we are going to cover. So in the OpenTelemetry demo that we have, it's currently deployed in a Kubernetes cluster. And what we want is to basically identify within a time range any CPU or memory that is currently increasing or decreasing. And what we want is to figure out, okay, if I look at the spans for this specific workload, is it going on the same directions? So if my CPU increase, do I have the response times increasing? Or the opposite, if my memory is increasing, do I have the response times increasing as well? So for that, we will go, of course, the response times will be on the spans, and the rest will be through time series, but we also want to get some Kubernetes details, so we will play with SmartScape. So that's going to be the actual exercise. So there will be a lot of baby steps. Yeah, let's start.
Okay, that sounds good. And just really quickly to remind everyone, we, as Henrik said, we do have the OTel demo app configured via the OTel collector to send telemetry data to Dynatrace and to enrich our data with Kubernetes metadata. We are using a very minimalistic deployment of the Dynatrace operator.
Yeah, good point. And one thing, because we're going to play with the SmartScape, and there are some IDs, and this is not coming. So just for those who never touch base on Dynatrace, and to be completely transparent on how it works, when you're sending OpenTelemetry data through a collector, where you have already added your Kubernetes metadata or OTel, whatever custom attributes that you have placed on the metrics, logs, and spans, when you're sending those data to Dynatrace, the first thing that is basically processing the data is called OpenPipeline. And OpenPipeline is going to be here to either run your custom pipeline that you may have defined to enrich, to filter, to transform the data. But if you don't have any custom pipelines, there are default pipelines, which means when an OTel signal is coming in, then the pipeline will be responsible to attach it to an existing entity. So an entity could be a pod, could be a service, could be a deployment, could be anything. So by going through these specific steps of OpenPipeline, this is where we have those SmartScape IDs, container IDs, service IDs, and everything that we're going to play with. This is not has been enriched in the OTel demo. It's when it hits Dynatrace, OpenPipeline will do this indexing of the data. And indexing is a key element because this is where you're are able to easily correlate things between metrics, spans, logs, and more.
Awesome. Okay, I'm excited to get started. So let me share my screen.
So the first, we're going to go to the notebook. Every query that could end up as a workflow or in a dashboard, we always start from a notebook perspective. And here, last time we saw that we had a fetch. We did some I don't remember if you played with time series, but here the first thing we are going to do is going through the data that I mentioned is the consumptions. So that's why the first thing that's going to be retrieved is not a bit SmartScape, is not going to be spans. We are going to start through by metrics. So let's create a new tile or DQL tile.
All right.
And then we're going to use to interact with our metrics. You see you have metrics here and you have time series. So metrics is, if you know the OpenTelemetry data structure, you have a metric and then you have a data point. So we can say that metric is the definition. So if you're looking for metrics with their attributes and everything, you will see them in those metrics dimension, and you can count the number of labels to figure out if it's an expensive metrics or not. But then if you want to see the values, then it's a time series. So here we're going to use time series.
Got it.
So time series. Now what we want is let's give a name to the metric. So we're going to retrieve two things. It's the memory usage and the CPU usage. So let's create a memory usage equal, and then here we're going to say average. And here we have if you type memory, it will search into the dictionary of so you have here you have memory, and then in Kubernetes you have the usage is the more precise usage is going to be the working set. We have the RSS as well, but here we're going to use the working set memory.
Okay.
And then that's the first memory. So we use the average container. Here it's a container. So we have to do DT Kubernetes to precise it's a so DT. I think, do we have the, if you go back to working set,
sorry,
we should have.
Are we getting rid of this?
Yeah. And then normally we do type working set. And then you have two variables, containers and DT. We want the Kubernetes one.
Got it. And is this the value that you were mentioning was coming in through OpenPipeline? Or is this a result of the Kubernetes enhancement that we did through the Dynatrace operator?
Excellent question. So this metrics, so if you're deploying the Kubernetes operator, here in this particular case, we don't use the instrumentation, everything is hotel, but we have one component called the Kubernetes monitoring. It's basically for those who've been using Prometheus, kubestat metrics exporters or node exporter that interacts with the kubelet to get the different metrics. It's similar. So the operator interact with kubelet to get the container resource usage and everything about throttling and everything. And this is basically metrics. So here we use the operator, and the component responsible to produce those metrics is the active gates, the Kubernetes active gates deployed with our operator, and those metrics are coming from those there.
Got it.
So now we have the working set. Perfect. Now let's do the same thing for the CPU. So we want the Kubernetes, so let's say CPU usage or something like this, and then it's going to be the average. And here, same thing. If you type CPU underscore usage, and we want this one, yes.
Right.
So now we have the two metrics, and then what we want is to define what are the details that we want to bring back. So we want to do a by. So here it's all the containers, and we want to split by 2 dimensions. One is going to be used later on, and the second one is just for filtering. So the first one is the SmartScape container. So type container or SmartScape.
Did I make a syntax error? Do I need a comma?
Oh, you need to put maybe he didn't. You see here the bracket is there's a space. So I think he didn't recognize it. So yeah, and then drop container. Oh no, sorry. You need a comma between after average.
Yeah. Ta-da. Okay.
And then here you have SmartScape something.
SmartScape container. Yeah.
That's the container ID or attached to the metric. And then we're going to bring the Kubernetes namespace name because we want to filter to the namespace that we are interested in.
Yes.
All right. So now we have our both metrics, and then go to the next line, and we're going to do like a normal DQL filter. So a new pipe new line. And here we can say filter with Kubernetes namespace name is hotel demo. Yeah, double equal. It's a condition.
Oh yeah, right. Gets me every time. Okay.
All right, and then if you run that query, just to figure out what we have,
wait,
you will see
is it double quotes?
double quotes.
Yeah. I seem to remember that got me last time. Boop, boop, boop.
Yeah, so here we have it recognize that it's a metric, so it's displaying the time series. So here, if you do option, you can see the format. Go to option.
Oh yeah, sorry.
Change to record lists.
All right.
So we can see here we have two arrays, which is two arrays. So memory usage and CPU core is two arrays of time series.
Okay.
So now what we probably want from this query, we want to be able to get the actual the delta. So what is this? So in you have an array.
Yeah.
For example, here you see the value is 18 dot something, and then
this here on the memory usage.
Yeah. And then next one is 1834. Next one is 1834. It seems to be quite flat, this one. And when you do the diff, it takes b minus a. So basically, it takes the value n plus 1.
Yeah.
And it divided by the value n. So why do we want to do this? We want to figure out if the next value is higher or lower.
Okay.
So we calculate the difference between the two values. So for this, let's add a new fields. So we're going to do fields add. And we are going to use, so let's create a name called CPU delta, for example. And then we're going to do same thing for the memory. And then here, CPU delta will be equal to a function that is array. So if you type array, and then there is diff. Go back. Go back. Remove to get array diff.
Oh, arrayDiff. Oh, I see.
All right. So here, basically, you have delta. Delta is the same thing, but it's going to be always positive. Here we are fishing for negative values.
Okay.
So and then we precise which metrics which array we want to do this.
Yeah.
In our case, we have two arrays, and here is the CPU usage. Here is.
Yep.
And then you can that's it. And then we can do another variable called memory delta, and we do the same thing.
And so memory usage, like so.
Yep. And then what we do next line, because now we have the two new variables exist. We're going to new line. We're going to go to there's
yeah, I know. I kept adding that. Stop it.
I have the same problem. Yeah.
Oh my God, go away.
And then what we're going to do is do an average. So here we have an array. So if you run that query, by the way, remove the pipe and then run that query so you can see the difference. And now you can see CPU delta. So the first value is null. And here you see minus 0.25, minus 0.29. So it's going up, going down, going up, going down. Sorry?
This is so useful.
And then you have a memory. You can see it's pretty much flat, except for the lasts.
Yeah.
So now we have the delta. What we want is to do the averages, because what we want is get average. So one average value of all those lines for this time frame. So let's do. We call it the mean. So it's the medium. So pipe fields add. And we're going to do the mean CPU delta and mean memory delta. And here it's going to be the array average.
And then here we do it off of the CPU delta?
Yeah. Yes. Perfect. And then we do the same thing for memory delta. And so here it's going to be returning only one value and not an array. So that's what we want.
Right. Excellent.
And then if you run that query, so you can check how it goes. can see here we have 0, 0, 1, and 0, 0. So it's very
Cool.
It's quite flat on this
Yeah.
value. You can see it's almost flat.
Yeah.
So what we want now is to create a new variable that, based on that value, if mean CPU delta is above 0, then it's growing.
Right.
Otherwise, if mean CPU delta is under 0, then it's decreasing.
Yeah.
And if it's 0, then it's stable. So let's create this new string.
Okay.
So it's going to be the trend. Call it CPU or CPU trend and memory trend.
All right. We're doing a field dot again, I presume.
Yep. Correct.
All right. So CPU trend. And what?
Here we're going to say, so it's going to be based on the condition. So if mean CPU delta is above 0, then we return, comma, then we return delta, growing. So growing.
Growing.
And then you after growing, you put a comma.
Okay. Oh, else.
And then here, and then else.
Oh.
Yeah, you need to
like that.
Yeah. And then you create a new bracket, a jitter brackets, because we want to.
This kind, the curly braces.
No, we don't even need it because it's going to be one instruction. So you can So here we do another if, because it's the if same thing. So here it's the mean CPU delta. So it's the opposite. If it's under 0, then it's going to be decreasing. And then comma after decreasing, and then we do if else. Here we do. Here it's going to be stable. No, if it's basically it's equal.
Oh, just else. Then it's stable.
Yeah. And then we do the same exact instruction for memory trend.
Great. Let's make sure my copy pasta worked. Okay.
All right. Now let's run that query just to check it.
Okay.
So we can see here, both here it's decreasing and decreasing.
Cool.
So we know that. So we have the trend for the metric. Now let's add. Now that we have the metric, what we want is basically attach maybe SmartScape details about the pod, about the service related to that workload, potentially the deployment. Maybe we want to have the Kubernetes manifest. So let's create a new line, and for this we're gonna join. So create a. In our case, it's gonna be a lookup.
Okay.
There's two ways of doing. There's a left join, inner joins, and right joins. Here it's going to be a left.
All right.
So here create this new structure. Yeah, and then close it. So then everything which is going to be in So now what we want is the let's figure out how we're going to join it later on. So put some space between those. So we're going to create a new.
Can
query inside of
I
this.
do a new line? Will it get mad?
Yeah, and put annotations, indentations, so then you see the new query.
Like that.
So the new query is gonna be here. What we want is to start from we have the container ID, which was the information that we got from the time series. So we're gonna start from SmartScape nodes.
Okay.
So nodes is the object itself. And here, the component that we are interested in is container.
Okay.
Uppercase container. Yeah.
Yeah.
Perfect. And then from there, we want to keep information from that container. So we're going to new line. We're going to say fields rename.
Do I need to have
pipe,
the pipe? Do I also need to have the pipe up here under SmartScape nodes? Is that?
No, not under. Yeah, no, not under.
Here?
Not
just
here.
Here.
Not here.
Just oh crap.
It's like you're doing a new query.
Got it. Should I? Okay. Cool.
Yeah, put the it's easier if you put it at the same level.
Okay.
It's for reading perspective, it's easier.
Okay, got it. That makes sense.
And then here the fields rename contain, and then what we want is to create a name, field, rename the fields. Here it's the container name called name. So here we're going to store it, change it to field rename container name is equal to name. So we are storing that into that new field. Oh,
what the heck? There.
Yeah. And then we go to the new line, and here we're going to travel. So we are the container, and we're going to use a function called traverse. And then traverse will help you to travel in the SmartScape. And the container, the nodes are the components, and the edges are the relation. And to travel, you use the relation. And here, what we want is to use basically the syntax, the dependencies, the verb. So here is the container is part of, so is underscore part of, and then the entity that we're looking for now is the Kubernetes pod.
So do I look for
new comma? Sorry, comma.
Okay.
And then K8 pod.
Pod. This guy.
Yep. And then we're gonna keep in memory two things what we want.
Okay.
From the first travel. So we are at the container. We will end up at the pod, and we're gonna say field comma fields keep, and we're gonna keep two things: the ID of the container, and the second one is the container name.
The container name.
Yep. Perfect. And now
we're going this container name is referring to the renamed container name here, right?
Yes.
Okay.
Yes. Now that we are at the pod, what we want is to travel to the service.
Okay.
Before we do that, maybe we could let me check. No, we pod name. We're gonna just rename the pod the ID because we want to keep the pod ID.
Oh yeah.
So we're gonna do a field rename before.
Here? Can we do a
no? So we can copy a field rename, and then we're gonna keep the under traverse. So we have because we're gonna retravel again, but before traveling we want to just rename a field. So we're going to store pod ID into
like that.
Yeah, and that is going to be the ID. So here it's the ID stored in the Kubernetes pod object. Now that we have this, let's traverse. So let's travel again. But here we're going to travel to the service. Why do we want to travel to the service? Because we want to easily join the spans later on. And having the ID of the service will make our life much more easier. So traverse, and then the verb is going to be run underscore on. Runs on. And then the entity that we are looking for is service. And here, because it's a backward direction, instead of a normal direction, we say service, and here we're going to say backward.
Do we have to specify? There we go.
It's always forward. And here in our case, we are at the service runs on a pod, but we are on the pod level, so we want to go backward.
Oh, I see, because of where we started.
Yes.
And just a really quick question: the traverse, is that only available for SmartScape nodes?
Yes.
Okay.
Yes, that's the only thing that it's very specific to the SmartScape.
Okay, got it.
And then what we want is to keep, so we are at the pod, we were at the pod level, so we want to keep two things: the pod name, Kubernetes pod name, and pod ID.
All right. This guy and pod ID.
Yes. And now that we are at the service, what we want to keep, so we're going to rename. Same thing, we want to keep the service ID, so it's going to be ID, and we want to rename the service name to be the name, because name is kind of generic, so it's better to store it on a dedicated variable. So service ID equal ID, and service name equal name.
Can I do a comma?
Yep. And now that we are at the service, unfortunately, you say, why are we doing this? Well, because we want to get to the deployment. So now we're going to traverse backward to the pod.
Okay.
And then once we are at the pod, we can go to deployment. So
Traverse again.
Yes.
All right. So all of this is so that we start with the container to get to the pod, and then from the pod we're hopping to the service, and then so this is like we're just hopping along the SmartScape nodes.
Yes.
Is that the path we're taking?
Yes, exactly.
Okay.
And by traveling, what we want is collecting data. And then so here we're making the query to collect all the data we need, and then we're gonna return it back to our main query, which is the time series. So what we want at the end is to get the pod name. So with the pod name, technically we have it. We should have it, yeah. But what we want is the Kubernetes object stored in the deployment. We want to have the service ID because we want to do so we are collecting information that we may use or we want to use later on. So that's why we're doing this travel.
Got it. All right. So where's our next?
So traverse now. Again, now that we did runs service direction backward, no, we don't need to do backward. It's going to be a direct, and we need to define the. There is a specific. We need to define the node ID. So the node ID. What is the ID that we're referring to? So runs on. We're going back to the Kubernetes pod. It's pod.
Okay. It's pod.
Underscore. No. Yeah. Underscore.
Sorry. Yeah. No, that was my bad.
And then here we're gonna say that we want to fields keep. We're gonna keep the service ID and the service name.
Okay.
And then what we want next one, comma. There's another comma, and there's another property called node ID. It doesn't. It's weird. Why?
Yeah, it didn't like that.
It seems if you node
it like it after service. After fields rename. Hang on. Maybe it didn't like it. That
is weird.
Nope. Huh.
Let's remove the fields rename if he doesn't like it.
Okay.
Normally it works.
I don't know. I don't know if it was the fields rename that it didn't like, but it was just weird that it didn't give us the auto name. Node.
I upper I and D.
Sorry.
It's node ID but with upper I. No. Another upper, just the I, node ID attached.
Oh. Node ID.
Yes.
Like that.
And then here, the key that we're going to use here is service ID. So he will complain about the fact that service name now doesn't exist in the fields keep.
Oh yeah, it's not liking it anyway, so. Sorry, what are we doing with this?
So here we're going to define what is the actual key that we're using. Here it's a service, it's our service ID.
Okay.
Because we renamed ID, so he's lost.
Yeah. No, but what are we doing with node ID?
We 2 points. Sorry.
Cool.
Yeah, and then we do service ID. So we define what is the ID.
Okay. Do I need curly braces?
No. Directly, you can put
this ID.
Yep, but something is. I don't know what's going on.
It has
I know. He's complaining. Yeah, he's complaining because we didn't finish the lookup. We need to find the source and the keep, and that's why. So it's normal. Don't worry.
Yeah.
Now, let's go back to the deployment. So we are the pod now. Let's go to the. We're gonna do traverse. So we are the pod. Now we can go back to traverse, and now the The relationship between the pod and the deployment is, again, is part of. So traverse is part of, and here it's not a pod, it's a Kubernetes deployment.
Part of Kubernetes. Like that?
Yes, and then, perfect. And then now we've been travel, we don't keep anything, we don't care, because we already have the information. And then now that we are at deployments, we want to get data. So for this, to make it simple for the audience to see, just copy the query that we have: SmartScape nodes, container, blah blah blah, until deployment. So then we can explain. So create a new DQL tile. So we're gonna fine tune. So because it seems very
there's a lot going on.
Yeah. All right. So now let's play that query.
Oh, something no likey. Please specify the parameter node ID explicitly, as the implicit default field ID does not exist.
Oh yeah, because here the ID doesn't exist. So our pod ID has been renamed. So we have to do. We are at the pod. We want to go to the service, but we rename pod ID into. So this, because of our renaming, is lost. Yeah. So we need to say after the at the end of the traverse, add comma.
Here.
Yeah, comma, and then same thing that we did, node ID. Yeah, and then pod ID. Yeah.
Oh, I see. Oh, okay. Makes it a lot easier to troubleshoot.
Yeah, because
this way compared to here. We're like, what's going on?
Yeah, because we renamed the ID, so then he's lost. That's why he asked me for this.
See. And again, I presume this node ID construct is only available for SmartScape nodes.
Correct. Because it's part of the traverse.
Yeah. Okay.
So just run that query, so then we can see. So here it's gonna go through all the containers, all the deployments, and everything. So we have lots of things. So what was interesting here, you look at this data, we have one field that comes back to the fact that we've been traveling. There is dt.traverse.history, and it's an actual array. So you can see here we have our first travel was container, and then the second travel was to the pod, then the third one was on the service, and then the fourth one was on the deployment. So what we want here, so we already at the deployment, so we already have the details, so we don't have to look at the last index of this array. What we want is to get from the array, the first index, we want to get the fields. Scroll up. So the fields is a container name. We renamed it, so we want to get the container name, and we want to have the ID as well, because it's stored by ID by default. We're going to do the same thing for the second index is the pod. We want to get the Kubernetes pod name. And then the third one is the service ID, where we want to have the ID of the service and the service name. So let's do this. So we're going to do a fields add after the traverse.
Okay.
And here we're going to use, we're going to create like a fields add. So let's create a field called pod name. And here we are going to say that this is basically dt.traverse.history. And here it's an array. So we're going to say, I want the index, that's the index number. The pod is the 1, because 0 is the first index, so it's index 1. And then on the second part of the array, so new pipe or new brackets or new lines.
Yeah, I see what you mean.
Yeah, here we want to define which field we are interested in, and in our case, it's the K8's pod dot name, I think. Or did we rename? Yeah, we K8's dot pod dot name.
Excellent.
Yep. And then, so that's the first field that we're getting back. The second field we want is to do something to get the pod ID.
Okay. So we do
it's ID.
That again.
No, you can do the same.
It's still the same array.
No.
No.
Do a comma and then create a new variable.
I see.
So pod ID, same thing, but here we're pointing to the ID. So you can copy probably all this instruction.
Are we still on the first?
Yes.
You're talking about. Sorry if I.
That's the index 0.
Yeah, this is the index. The index 0 is I see. This is a 0. is this is the whole array, right? And then so index 0 is up to here, and then
Container.
index 1 is here, 2 is here.
Yes.
Okay. So now you said we want to get index 0.
Yes.
All right.
No, index 1,
Oh,
index 1,
index 1
because
still.
we are still at the pod. We're still at the
Still
pod.
at index 1. So we
And then we want the ID. The field is called ID.
Okay. Got it. Sorry, I'm just correlating it to
And then copy the entire field. It will be faster.
Okay.
So we're gonna create the same thing for the index number 2 is the.
Are we copying this whole line?
No. Just pod ID. So
Just
because we're
the
gonna create
pod ID.
3, we need 2 things. We need the container name, which is in the it was the index 0. And then what's the most important one to go to the service? We want to get the service ID and the service name. So which is the index number 2, or not 2. Yes, number 2. So here let's do a container name. So it's gonna be called container underscore name and index 0. Index 0.
Yep.
And then the container underscore name.
Got it. Sorry.
Yeah. And then now that we have the container, let's do the service ID.
Okay.
And then you can paste and then here it's the index number 2.
Index number
and
2.
ID.
All right.
And then we can take maybe the service name, because it could be useful to get it. So service underscore name.
All right. And we do index 2
and then the field is service underscore name.
Got it. Okay, so
let's run that query.
Okay.
And then you will see that in the bottom we can see we have somewhere scroll up. No, it should be a
here.
service ID. You see you have the service ID, you have the pod, you have everything. Now one thing we want to add here, it's fields add. We want to get the Kubernetes object.
Okay.
So let's create so we already have it, but let's name it K8's object, K8's, for example, and then equal to the K8's dot object, I think.
And what's K8's object?
It's, you see here, you have it on the actual results. It's the actual
I see.
YAML file in a JSON format.
We
have the actual YAML file.
Oh, I see, the manifest, basically.
It's the manifest.
Yeah.
Yes.
Okay. Cool. That's cool.
So now we have the query. Let's copy everything that we have here.
All right.
Put it back into our not run it, but copy the entire query.
Yeah.
And then put it back to our lookup that we had initially.
Fantastic.
And then we can finalize the actual
what we're looking up.
This
is basically like similar to like an SQL like in, right? Where blah 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 in blah.
Here we're doing like a join,
right.
Left join.
Yeah.
So now you go on the last line, go to the last line, comma.
Like
that? Just no, not here. No, in the main query, not
like here.
No, in the main query. This is we only on the subquery. We want to
like
go
here.
Here, yeah, comma, and then here. This is where we're going to do linking.
Oh, I
source
see.
field. So source field is our time series, and we have DT SmartScape container, which is the idea of the container.
This guy.
And then we are going to link it to comma. Sorry.
Yeah.
To the lookup field. So that's inside the second query, and here we want to look it to. The field is called the container ID, I think. No, container.
Is it container?
Oh shit, we didn't.
Did we
forget to get...
Possibly.
Oh yeah, we took the container name, but not the container ID.
That's true.
So just add on the fields add on the line number 17. You see, you have container name on the right side.
Yep.
So do the same thing. So copy the container name.
I see.
And create a container ID.
Got it. Where the okay, here. This guy. container. Oopsie.
Here it's ID. It's ID,
Yeah,
not
yeah,
container, but ID.
yeah.
No. It's ID. The field is going to be ID anyway.
Oh, the field is called ID, and
Yeah.
and then this guy needs to be container name. I mean ID. Sorry.
ID. Yeah, and now we have it. Perfect.
All right.
So now we can say we want
Sure.
container ID.
ID.
And now we're going to define what we want to keep. So we're going to say fields. So comma.
Oh.
So and then here we say which fields we want to bring back to the main query. So we want to have the container name.
Yeah.
We want to have the K8 object. We want to have the K8's the pod name.
Okay.
It's a container name. Yeah, container name. Pod's name. We had a pod underscore name, I think.
Yeah, we do.
Comma.
Oh, sorry.
Comma,
we duplicated container name. Sorry. Pod name. Yeah.
Yeah, and then we want to have the K8's deployment.name. We can put also maybe. Yes, that comes from the deployments. And then we want to have the K8's namespace name. And then last. Yeah, and last we want to have the service ID and our service name.
Okay.
Okay, so let's run that query.
Dun, dun, dun.
And you see that our metric now has those two things. And because it's the matching here, you see the matching didn't happen because it's a left join. You see container name is null and everything is null. So let's put a condition to say that we're going to filter where is not null. So new line, we do a filter. Filter is not null container name or container ID or whatever. But one of the fields that we get coming from
not null container name.
Yes.
So
perfect. Now we have it to play.
And now we should get non-null values.
Yeah, and then everything is attached. Now that we have everything, let's get our spans.
Okay.
So let's do another lookup.
Okay. Shall we start a new DQL query?
No, I mean here it's going to be fairly simple.
Okay.
We just want to fetch the spans from a service and create a time series with a duration. So fetch spans.
Fetch
spans.
Yeah.
And here we're gonna do. Here I'm making it very simple, but we could imagine to be more advanced. But let's make it simple.
Okay.
There's a function called make time series.
Okay.
Yep. And what we want here, it's gonna take several arguments. So let's put a name to that time series. So let's say put percentile, for example.
Sorry, what? Oh, percentile.
Yep. And here we're gonna define what.
Oops.
Yeah, equal, and then here we're gonna put the percentile.
Percentile, can't spell. Yes.
Yeah, and then here we're gonna say use the function. We're gonna do the percentile 95 of duration.
Okay. Hit the.
No.
Percentile.
Reuse. Yeah.
Percentile. And.
Duration, because the field duration is on the spans.
Okay. Oops.
And then 95.
Like that.
Yeah, and then once we've close everything and then put a comma, and now we're going to define what is the dimensions for that specific time series.
Okay.
So let's put, for example, DT SmartScape service, because that's the service name.
DT dot.
You forgot to.
Of course. DT SmartScape
service ID. Yeah, service. Yep.
Yeah.
And then let's add another one. We could just for fun.
Okay.
If we you need to make
probably curly braces, right?
Yeah, curly braces. Yeah.
Otherwise, it gets mad.
Here, let's put remove. Yeah, remove the comma and or redo the comma. So then he will suggest fields.
Oh yeah, got it.
And then is there like an endpoint or something URL? What do we have?
Endpoint name.
Endpoint name. Yeah, perfect. All right, now we have this, and then that's what we are going to return. And now let's end up our lookup and says how we're going to link things. So here we are the service. So yeah, source fields. Source fields is the field was the service ID, because this is the service ID coming from our time series.
Yeah.
Yeah, and then lookup field is the DT SmartScape whatever.
DT SmartScape service. Okay.
Yes.
All right.
And then fields. What are the fields we want to retrieve? So we want to retrieve two fields is the percentile.
Yes.
And our endpoint name.
Cool.
Here it is.
All right.
And now then we can run that query.
Okay. So
now endpoint ingress, and then you have the time series. So here we have we started from from the actual time series, and then we are at the service with the actual duration. So we are linking resource usage with service usage.
Cool.
By this query. And then we can go even further if you want and do the same thing that we did before. Percentile is an array, so we could do arrayDiff, arrayAvg, and then same thing, the same thing we did in the beginning.
Right.
So do the trend, but based on the duration. So now, if you want to do this, we copy the line 3, 4, 5, 6.
Okay. Oh.
Yeah, this one. Yeah, perfect.
All these?
No. Oh, yeah.
All these?
Those.
Yeah.
And then we'll here. No. And then put it after
went too far.
Yeah. And then we can paste this. And then now you're referring to CPU. So here we just one field that we want to do things. It's the what it says. It's the duration percentile. So I'll remove. So here we have the CPU delta and memory delta.
Yeah.
We're just gonna have the duration delta.
Duration delta. Okay. And then
here you have to say percentile.
Oh, yeah.
And then you can drop the memory delta stuff. Yeah.
Cool.
And then we do the same thing here. Mean duration delta.
Yeah.
And then here it's the duration delta.
Oops, yeah. Yeah.
And then
drop
the memory.
And then duration trend, right?
Yeah. Yeah, and then you can drop the last one.
We don't need this guy. Yeah.
And then now we have the trend.
Mm-hmm.
Now let's do a filter. Let's say, and then we want let's say where duration trend is equal to CPU trend, or duration trend.
Or is that correct?
Or duration trend is equal to memory trend. And then let's run that.
Okay. Ooh.
Here, we know that, for example, when the duration is decreasing, let's figure out it should be somewhere we have the CPU. So here we could even be more complex, saying that figuring out if it's related to CPU memory. But if you scroll up to this record, you should have somewhere. Here it's memory. So if when the memory decreased, the response time decreased.
Mm-hmm. Yeah, the memory trend is decreasing and we're seeing the duration decrease. Cool. Yeah, which makes sense, right?
Yeah, or no. I mean, sometimes yes, sometimes not, but yeah.
But I guess it can help to identify if there's something going on, because even if you're seeing like the memory is decreasing but the duration is increasing, which we're not checking here, so I guess we'll never see that. But it's interesting to see that we have that correlation, right?
Yeah, but we can even go further with there's more complex functions for statistics. But at least here we see we use two lookups.
Yeah.
Starting with times, we started with a time series. We went to a lookup to get some details from the SmartScape, and then once we had the service ID and all the things that we needed for the rest, we joined the spans to attach the service ID, where we created a new percentile.
Yeah.
And then we started to do something. So this is a 28 lines of query.
The most complex DQL query I've ever written. There's a lot of knowledge in this query. I appreciate that.
You're welcome. So yeah, that's just an example. Again, you can. There's so much thing we can do with Grail. If you know the data and how it's structured, it's fairly easy to start playing with the data.
Well, this is awesome. I mean, we've covered so much stuff here. So yeah, like you said, there's so much more that can be covered. But thank you very much for this demo query. I think it illustrates a lot, not only from a DQL perspective, but also the kinds of cool things that you can do with the data, so that you can make the most out of your OTel data, which is awesome.
Agree.
Yeah. Great. Well, thank you so much, Henrik, for coming back onto the show and giving us this this demo. And I'm sure I'll come up with fun new use cases to bring you back again soon.
I love to. All right. Thanks.
All right. Thank you. Bye.
Bye.